So this is one question which I skipped from the matrix part of it. So I'm going to go back and do that before we continue with determinants. We started with the determinants last time. This is an important question. A little bit trigonometric simplification is involved. That's why it is important. Not because of the matrix concepts involved in it. No, not so much of it. So look at this question. There is a matrix A given to you, which is 0 minus tan alpha by 2, tan alpha by 2 and 0. Then I is equal to 1, 0, 0, 1. And your question is to show that I plus A, that's the left-hand side, I plus A is equal to I minus A into, then there is a matrix on the right side. So this is what we need to prove. So obviously we are going to start with the LHS. So you copy the LHS. You will write the value for I, you will write the value for A, add the two, you get the LHS. Okay. So once you are done with the LHS, then you will go to the right hand side, start subbing in the values, try to do some simplification, try to apply some trigonometric results, and finally you will get the answer. But it's a little bit tedious. So let's start with the left hand side of it carefully. And if you don't understand any of these steps, immediately stop me and ask. Okay. If you're just keeping quiet and sitting there, absolutely no point in being with me. Okay. So we start with the LHS. The LHS is I plus A. We copy the LHS. And then I'm going to sub in the values. I will sub in the value of I and A into this. I is, copy it, 1, 0, 0, 1 into A. A is 0 minus tan alpha by 2. Then I have tan alpha by 2 and 0. That's the LHS. And then I need to multiply this. Oh, it's I plus. I'm sorry. I forgot to put the plus sign in between. It's not multiplication. It's I plus A. So I copied my I plus I copied my A. And to add two matrices, just add the corresponding elements. So I'll get 1 minus tan alpha by 2. Then I have tan alpha by 2. And then 0 plus 1 is 1. So that's the LHS and I leave it there. Now I'm going to start with the RHS. The RHS. And the RHS is I minus A together in one bracket into, then I have cos alpha minus sin alpha, then I have sin alpha and cos alpha. I copied the RHS. Now I'm going to sub in the values of I and A into this in one bracket and then multiply. Okay, so I'm going to copy my I and A into this. I is 1, 0, 0, 1 minus A is 0 minus tan alpha by 2, tan alpha by 2 and 0. Close the double bracket. This is for I minus A. I did the first part of it, I minus A. Into, there is another matrix there, which is cos alpha minus sin alpha and cos alpha. Everybody okay until there? Yeah? Okay. So now what we do is, inside the bracket, it is I minus A subtraction. And to subtract two matrices, you will subtract the corresponding elements. So that's going to be 1 minus 0 is 1. 0 minus tan alpha by 2 is tan alpha by 2. 0 minus tan alpha by 2 is minus tan alpha by 2. And 1 minus 0 is 1. So this is what I have there. Do you all understand until here? Sahil, is it okay until here, whatever I have done so far?
Yes, sir.
Okay. So now all of you should listen to me, what I'm going to do now. I simplified my I minus A into one bracket. But do you see the next bracket? In the next bracket, I have got this trigonometric term sin alpha and cos alpha. But the angle in the first matrix is alpha by 2. Angle in the second matrix is alpha. The angles don't match. So what I'm going to try and do is to make the angles match in both the places. So even in the second matrix, I want alpha by 2 to come. And we have a set of formulae for that to change it into half angle tan formula. Nahat, can you tell me what's the half angle tan formula for cos alpha?
Yes, sir. Cos alpha by 2 equal 1 minus cos alpha divided by 2. I mean 1
Actually,
plus cos alpha by 2.
uh, I don't think it is right. Anyone else?
Is it the tan alpha minus tan alpha by tan 1 minus tan alpha?
1 minus tan square alpha, isn't it that way? 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. Anyone remember that formula?
So cos 2 cos
Tell me, Reina.
so cos alpha is equal to 1 minus tan square alpha by 2 divided by 1 plus tan square alpha.
That's the formula. You guys should learn it. Okay. So cos alpha is 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. Just 1 second, okay. Humera, sorry, I didn't see your message earlier. Okay. So cos alpha is 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. And minus, anyone remember the formula for sin alpha like that? There is a half angle formula for sin alpha also in terms of tan.
So 2 alpha
2
2
tan
tan
alpha by 2
alpha by 2 divided by 1 plus
divided by what
1
is it?
plus tan square alpha by 2.
1 plus tan square alpha by 2. Guys, these formulae from class 11 are so very important. You need to remember them, and you should be able to apply them whenever it is needed. Okay. So what are we doing? We write cos alpha in the tan alpha by 2 format. 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. And that's cos alpha. And sin alpha is 2 tan alpha by 2 divided by 1 plus tan square alpha by 2. But I need to use that everywhere. Okay, you guys finish it. In the meantime, I'll just quickly tell Humaira and Neha what is happening here. This is a question from matrix section which I had skipped. Okay, Neha. So what we are going to do is, you can see the question there. And now what we do is we'll copy the LHS. I did copy the LHS. The LHS is I plus A. So I copied I plus A. I know what is I. It's given to me in the question. Otherwise also we know. And what is A, they told you in the question. I copied it. And to add two matrices, what do? Add the corresponding elements. 1 plus 0 is 1. Then 0 minus tan alpha by 2 is minus tan alpha by 2. 0 plus tan alpha by 2 is tan alpha by 2. And 1 plus 0 is 1. So I did I plus A. That is my LHS. Then I copied the RHS. The RHS is I minus A. I'm just copying the RHS from there. I minus A into cos alpha minus sin alpha, cos alpha. I just copied the RHS, kept it like that. Now what I do is, I know the value for I wrote it. I know the value for A, I wrote it, but all together into one bracket. Okay, that's my I minus A. Just subtraction in between I and A. And in the next bracket, I have this matrix which I copied as it is. Humaira, do you understand what's happening?
Yes, sir.
Okay. And then I did the subtraction. 1 minus 0 is 1. 0 minus tan alpha by 2 makes it tan alpha by 2. 0 minus tan alpha by 2 is minus tan alpha by 2. And 1 minus 0 is 1. Neha, is that okay?
Yes, sir.
Okay. And then also we did something. Since the first bracket is in terms of tan alpha by 2, we wanted the second matrix also to be in terms of tan alpha by 2. And then there is a set of formula. Cos alpha is 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. It's a formula. And sin alpha is minus 2 tan alpha by 2 by, I'm sorry, minus is already there. Sin alpha is 2 tan alpha by 2 divided by 1 plus tan square alpha by 2. This is a formula from class 11. I'm going to copy that, write the formula everywhere. So this will be 2 tan alpha by 2 divided by 1 plus tan square alpha by 2, and cos alpha is 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2, and close the bracket. Have we all reached until here? Aishi reached until here?
Yes, sir.
Okay. So now if everybody reach here, Shlok, did you reach here?
Yes, sir.
Okay. Now what we are going to do is we are going to make a substitution. The reason being, this expression, at least to me, it looks horrible. If I need to work on this, it looks very difficult. So what I'm going to do is I'm going to make things look easier, only look easier. To me, what I'm going to say is I make a substitution. I'll say let tan alpha by 2 be equal to some letter for the time being. I'm going to call it as t, matches with tan, you see. So I'll say make a substitution. Let tan alpha by 2 be replaced everywhere by t. So it's going to look much better now. So it's equal to, all of you should replace, wherever tan alpha by 2 comes, you should replace it by t. So it's going to be 1, t, minus t, and 1. Replace everywhere by t, the letter t. And into the next bracket, it's pretty bigger one, matrix. It's 1 minus t square by 1 plus t square minus 2t by 1 plus t square. In fact, it is the same thing, but looks easier. 2t divided by 1 plus t square and 1 minus t square by 1 plus t square. Everybody see this? Yeah? Now listen to me. Purvika, in the second matrix, there is something common factor. Can you tell me what is common in the second matrix? What is common in the second matrix, Purvika?
The denominator 1 plus t square.
The denominator 1 plus t square. Or rather, I say it is 1 by 1 plus t square. 1 by 1 plus t square is common out of the second matrix, which I bring and place it right in front. Look at that, all of you. So this is what I have. This 1 by 1 plus t square came out of the second matrix. If you are not able to understand, please tell me. This is what I have now. Trainer, everything is okay?
Yes, sir.
Trainer, can you tell me what should I do
So
next?
should we multiply the matrix?
We should just multiply the two matrices now. We are going to multiply the two matrices. So I'll keep this 1 by 1 plus t square outside, and I'm going to multiply the two matrices. And how do I multiply the two matrices? The row there will get multiplied with the column. I multiply the first row with the first column. Usual matrix multiplication. A 2 by 2 matrix into another 2 by 2 matrix is going to give me another 2 by 2 matrix. So this is the first row goes along the first column. I'm going to multiply. Pranavi, multiply and tell me what do I get? 1 into Pranavi?
So it is
What will I get if I multiply? 1 into
1 minus c square
t square
plus
plus t into 2t, which is 2t square. Yeah, it's okay. So 1 into 1 minus t square is 1 minus t square plus t into 2t is 2t square. Do you all see that? Yeah? Okay, Vedant, tell me the next term.
Yes, sir.
First row into the first column is finished.
So the next
Now,
term will be we'll multiply 1 and t with minus 2t and 1 minus t square. So we'll get minus 2t plus
1 into minus 2t is minus 2t plus
t into minus
t into 1
minus t square. So we'll get
Can
t,
we write it as
t minus t cube.
Very good. Okay, so that's the second element there. And Tarun, multiply the second row with the first column. Second row with the first column.
Yes, sir. So it will be minus t plus t cube.
Oh, okay. Minus t into 1 minus t square in brackets. And when you open the bracket, minus t and minus into minus is plus t cubed. Yeah.
And
Plus,
plus 2t.
Arun, plus 2t. 1 into 2t is 2t. Do you all see this? The second row from here goes along the first column. So minus t into 1 minus t square minus t plus t cubed plus 1 into 2t is 2t. And then second row into the second column now. Second row into the second column. So minus t into minus 2t is 2t squared plus 1 into 1 minus t square is 1 minus t square. This is what I get. Check all of you. All right, I'm going to simplify this inside that matrix now. So when I try to simplify this, this is 1 by 1 plus t squared into 1 plus t squared minus t cubed. I get t cubed plus t. I get 1 plus t squared. Everybody reach here? There is a bit more simplification possible. 1 by 1 plus t squared into 1 plus t squared. Copy. Humaira, tell me in the next term what is common, Humaira. Humaira,
Yeah.
what is common in the next?
Minus t.
Negative t. Negative t into what is balance? 1 plus.
T square.
Did he say something?
T square.
T square. And then Neha, tell me the next row. What happens in the next row?
So we can take t out as common.
And so 1 plus t square and then 1 plus t square. Neha, I can do one more thing out of this matrix. What is that?
So we can take 1 plus t square out common.
Okay, 1 plus t square comes out divided by 1 plus t square. Into balance will be 1 minus t and 1. So outside term cancel. So it's only the matrix 1. By the way, Sahil, what was this t? Sahil?
So it was 1 minus.
No, t. What did he put t as?
So it will be tan alpha.
Tan
1
alpha by
minus tan alpha, yeah.
tan alpha by 2, right? So
Yes, sir.
t is tan alpha by 2 and 1. Did I get the same thing as the LHS now? Sahil, check and tell me. I can't see my LHS, that's why. Did I get the LHS same as RHS?
Yes, sir.
Was the LHS the same thing?
No, it was 0 minus tan
Really?
alpha by 2.
LHS? What did you get LHS as, Sahil?
Oh, yeah, okay, sir. I thought I was reading from a question.
And we got the LHS.
Yeah, we got it, sir. Yeah, yes, sir.
Yeah, LHS and RHS gave me the same answer. So I say LHS equals RHS. LHS equal to RHS. Therefore, proved. Yeah, done. Everybody okay? It's a bit tedious kind of a simplification, and you have to do like this systematically, and it's easy. The thing is, you have to repeat these questions multiple times. Take it out, do it. The questions I skip, you have to repeat them again. Everybody okay? We can move on. Okay, the last thing which we did was, Sahil, did you finish writing?
I finished.
Okay, and Neha finished writing?
Yes, sir.
Humaira, did you actually finish writing?
Yes, sir.
Okay. So we are moving ahead. We were talking about this determinant. We did these questions last time. We tried to expand some determinants, if you remember. I think that is the last question, somewhere here, is the last question we did, evaluating a determinant. I hope all of you remember, okay? So I'm going to do some more questions on determinants and then the applications of it, okay? So look at this. This is on the determinant sheet. I don't know whether I have shared it with you, but I will definitely send it otherwise. Okay, you can check it. So this is evaluate the following determinants. That's the question. All of you remember how you do this, right? Yeah. So we do the alternate questions. Question number 1, 3, and then 5. Okay. So question number 1, evaluate the following determinants. So we're going to start evaluating this. The first one, copy the determinant. Question number 1, determinant 2, -1, 5, and 6. Okay. So it's a 2 by 2 one. Directly we do it. Now, how do we expand this determinant?
Yes, sir. We cross multiply the opposite.
Cross multiply. AD minus BC. Yeah. So what
Two,
do I get? 2 into
12 minus
5.
-5.
If anyone has forgotten, you should always cross multiply like that first. AD minus BC. So 2 into 6, 12. Minus C into D is -5. So 12 minus, so this, in case anyone has forgotten, determinant A, B, C, D. How do we evaluate? Always do AD first. AD minus BC. That's how you expand a determinant. Determinant A, B, C, D will be AD minus BC. AD minus BC. Okay. So this is going to be 17. Okay, then question 3. So that is determinant x, x minus 1, x plus 1, and x plus 1. All right, so we need to expand this. Aishi, tell me, how do I go about it? Aishi, quickly. Aishi.
Yes, sir.
Yeah.
So first one will be x into x plus 1.
X
Which
into
will be
x
x
plus 1. Okay,
and the
then
second will be x plus 1 into x
what
minus
sign
1.
do I put after the first product?
Minus
Minus x plus 1 into x minus 1.
x minus 1.
Yes, it's AD minus BC. Do AD, the diagonal elements you cross multiply first, subtract the other product. When you open the bracket, it is x squared plus x and minus inside the bracket because of the minus sign. It looks like a plus b into a minus b, x plus 1 into x minus 1, a squared minus b squared, x squared minus 1 squared. That is x squared plus x minus x squared plus 1, which is going to be x plus 1. That's going to be x plus 1. Okay. Question number 5 next. Question number 5. Question number 5. Because if you all have finished that. Question number 5, to find just the determinant of that matrix given to you. There is a matrix A given to you and you have to find out what is determinant of A. Determinant of A. Okay, try it. You will copy the determinant and you know for 3 by 3 how you do. You have the position signs plus, minus, plus, yeah. So we copy determinant A. Determinant A is equal to determinant 1, 1 minus 2, 2, 1 minus 3, 5, 4 minus 9. And then we start expanding. How do we expand the first element? 1 into its minor. The minor of it. Maybe I show the minor. You know you start with plus sign, right? You have a plus sign. The first element is 1 into its minor. What is the minor of the element 1? Delete the row and the column it belongs to. Then you can see 4 different numbers there and that will form its minor. 1 minus 3, 4 minus 9. 1 minus 3, 4 minus 9. Then the next sign is always minus. It's plus, minus, and then plus. Minus, then pick up the element from the second position, which is 1, and into its minor. Into its minor, when you say delete the row and the column it belongs to, so you can see 4 different numbers there, and they are 2 minus 3, 5 minus 9. 2 minus 3, 5 minus 9. Then plus the next element. Next element is It's always plus next. And the next element is minus 2. Yes, Aishi? Good. The next element is negative 2 into its minor. Into its minor. What is the minor of minus 2? Yes, Reina. Delete the row and the column it belongs to. You can see 4 different numbers. So I delete the row and the column it belongs to. 2, 1, 5, 4. 2, 1, 5, 4. Now later on you can probably skip this step and do this in your head, like the step which I am doing next. So 1 into cross multiply AD minus BC. AD, the diagonal elements. 1 into minus 9 is minus 9 minus 12. Minus 1 into AD minus BC, cross multiply, minus 18 minus 15. Minus 2 into cross multiply. 2 into 4 is 8 minus 5. So that's going to be minus 9 plus 12 is 3. Minus 1 into minus 18 plus 15 is minus 3. Minus 2 into 3. So that is 3 plus 3 minus 6. Did you guys get 0? Aishi, did you get 0 there?
Yes, sir.
Okay. Shlok, did you finish?
Done, sir. I got 0.
Pranavi, finish? Umaira?
Yes, sir.
Okay. If everybody finished, we move on. Okay. So question 7 next. Just to evaluate that quickly. Determinant. Evaluate that determinant. Go ahead of me. You should finish it before me. So that's a given determinant. I'm going to copy the determinant first. And then I know how it goes. The first sign is plus. So if it is plus, you don't have to necessarily write it. I just want to show that the first one is first position sign is plus. Then I pick up the first element. Element is 2. I copied it here, 2. Then for the element 2, delete the row and the column it belongs to. You can see 4 different numbers there. 4 different numbers. And they are 7, 8, minus 3 and minus 2. The 4 different numbers we get. That forms a determinant. So determinant 7, 8, minus 3, minus 2. The next sign is minus, subtraction. Yes, that one good. Pick up the element from there. The element is minus 1 into its minor. The element is minus 1. Delete the row and the column it belongs to. Yes, Reina. Now copy the numbers. Minus 6, 8, 3 and minus 2. Plus the next element is 5 into its minor. 5 is the element. Delete the row and the column it belongs to. Pick up the 4 numbers. You will get minus 6, 7, 3 and minus 3. Then you start expanding 2 into minus 14 minus 24 plus 1 into 12 minus 24 plus 5 into 18 minus 21. So that is 2 into 10 plus 1 into minus 12 plus 5 into minus 3. 20 minus 12 minus 15. That's 8 minus 15 is it? Minus 7. Is it negative 7?
Yes, sir.
Okay. Everybody finish that? Neha finish?
Yes, sir.
Okay. If you all have finished, we are on question number 10 next. Question number 10. Okay, so this is a proof question, right? Show that. So show that questions, how do? We do the left-hand side, then we do the right-hand side. Show that both give you the same answer. Okay, so what you need to prove is determinant of x times a is x cubed times determinant a. Like inside the determinant, there is an x. If you bring that out, It doesn't come out as x. It comes out as x cubed. That's what they are saying. Okay, so I need to do the left-hand side. If I need to do the left-hand side, the first thing I need to do is, Vedant, what should I do for the left-hand side? What is the first thing I need to do? Vedant.
So first we have to multiply it by x because
Exactly.
it is in the determinant. We have to multiply the determinant by x.
Exactly. First, you should find x into a. Then take its determinant. So I'm going to do that. Determinant of xa is equal to determinant of x times a. And to multiply a matrix by x times a. X times a. If I want to multiply the matrix A by X, I multiply every single element of A by X. So it's going to be 3X. It's going to be 3X minus 4X. One second. Then I have 1x minus 2x, 3x, and 1x. That's determinant of x times a. So I need to now find out the determinant of it, which we do the normal way. We start with the first element. The first element is 3x into its minor. The minor of 3x. How do I find out the minor of 3x? Delete the row and the column it belongs to. Copy the remaining 4 numbers. So it's going to be x minus 2x, 3x, and x, which is equal, no, it's not finished, minus the next element. Next element is minus 4x into its minor. What's the minor of minus 4x? This is the element. Delete the row and the column it belongs to. You can see there are 4 different elements. So it's going to be x minus 2x, 2x and x. Then plus the final element. The third element is 5x into its minor. 5x is the element into its minor. Delete the row and the column it belongs to. The 4 numbers are x, x, 2x, and 3x. Then you start expanding. So that's going to be 3x into, I do AD minus BC, normal multiplication. I'm sure some of you must have already finished. It's x squared minus 6x squared. 3x into 2x, 3 into 2, 6, and x into x is x squared. This is plus 4x into, cross multiply again, AD minus BC, which will get me x into x, x squared, minus, look at the remaining product. Yes, Reina. So when I cross multiply like that, it's positive into negative is negative 4x squared plus 5x into cross multiply. You will get 3x squared minus 2x squared. So that's going to be 3x into 7x squared plus 4x into 5x squared plus 5x into x squared. That's 21x cubed plus 20x cubed plus 5x cubed. That is 45x cubed. Reina, is that what we get on the left-hand side?
So
So
46.
46.
40? Oh, yeah, it is 46. It is 46, yes. 46x cubed. That's the LHS. So I did the LHS. Now I need to do the RHS and show that. Yes, Tarun. Okay. So we're going to do the RHS. The RHS, if anyone had trouble, you should please listen to me or you should ask. So the RHS is x cubed into determinant A. That's x cubed into determinant of A. 3 minus 4, 5 1, 1, minus 2, 2, 3, 1. So that's x cubed into determinant A. So we're going to expand that. X cubed will stay outside and then do normal determinant evaluation. We already did many questions, so you know how to do it. 3 into its minor. Purvika, did you finish?
No, so I'm doing it.
Okay. Minus 4 into its minor. That's minus 4. Delete the row and the column it contains. The remaining 4 numbers. Oh, I didn't show minor this time. I was trying to do it in my head. But if you want to show the steps, then it will go like this. First element 3 into its minor. 1 minus 2, 3, 1. You can skip this step. Minus 4 into its minor. 1 minus 2, 2 and 1. Plus 5 into its minor. 1, 1, 2, 3. That's x cubed into 3 times 1 minus minus 6 plus 4 into 1 minus minus 4 plus 5 into 3 minus 2. That's x cubed into 3 into 7, 21 plus 4 into 5. That's 20 plus 5. That's 46 x cubed. So LHS equals RHS and hence verified or proved. LHS equals RHS. Yeah, anyone had trouble with any of these steps? Please tell me now. Shlok, did you get it, Shlok?
Yes, I got it.
Okay. Okay, if you all have finished, let's move ahead. Purvika, you finished now?
Yes, sir, done.
Yeah. So basically, from what we did, we have a result. So I just want to quickly discuss that result. Look, this is what we did. This is what we proved. Determinant of x times a is x cubed times determinant a. When you take this x out of the determinant, it comes out as x cubed. That's because it was a 3 by 3 matrix. Now, what if it was a 4 by 4 matrix? Then when x comes out of the determinant, any guess, Vedant? If it was a 4 by 4 matrix, when x comes out of the determinant, what would have been the right hand side? Vedant?
So x to the power 4
X to
into
the power of
determinant.
4. If it was order 2, it would have been x squared and so on. So I have the generalized result here. Look at this. Determinant of x times a will be x raised to n times determinant a, where n is the order of the matrix. If it is a square matrix, it will come out as x square. If it is a third order matrix, x cube. Yeah, depending on the order. If the order is n, it is x raised to n. I think you should write it down. Okay. As an example, determinant of 3a will be 3 cubed times determinant a. Yeah. So where this power 3 is the order of the matrix. Okay, depending on the order. If the order of a was 2, it would have been 3 squared into determinant a. Does that make sense to all of you? Yeah. Okay, so look at the next question. What I have written there. It's this particular question. Look at that. If a is of order 4, then determinant of 2a is going to be what? Okay, so that's a question. If a is of order 4, what is determinant of 2a going to be? Pranavi, if a is of order 4, what is determinant of 2a going to be? Pranavi? Okay, Neha, tell me. If A is of order 4, what is determinant of 2A going to be?
So it will be 2 raised to 4 into determinant of A.
It will be 2 raised to 4 into determinant of A. Okay, please write it down. It's written like an MCQ, okay? Like, what is the answer? So usually people tend to pick up probably this answer. And if it was -2, they would write 2 times determinant A. So you should remember it's not that way. Whatever number comes out of the determinant, because determinant sometimes we misunderstand as modulus. It's not modulus, it's determinant. From the context you should know. So it comes out as 2 raised to 4. Another one. Okay, look at this. Can you all write down the answer to this? The next question there. If A is of order 3, then what is it's a third order matrix. So n is 3. What is determinant of -2? This is what I was talking about. Sometimes you may misunderstand this determinant sign as absolute value sign, modulus. And modulus of -2, you will write it as 2, obviously. So this will turn out to be 2 times determinant A, which is wrong. This is not modulus. It is determinant. Sahil, can you tell me what is the answer to this question?
-2 raised to 3 into determinant of A.
Determinant A. And -2 raised to 3 is actually -8. So your answer is -8 into determinant A. Okay? This is the answer. -8 into determinant A. Everybody okay? Yeah? Hard?
Yes, sir.
Okay. So another example written here, you see. Suppose I have like that. Okay? Determinant of -A. Determinant of -A. If the order of the matrix is 3, what is the answer to this going to be? Aishi, what is determinant of A going to be if the order of the matrix is 3?
Sir, option C, -8 into.
It will be -1 to the power of 3 into determinant of A, which is minus of determinant of A. That's the answer going to be. Yeah? Okay. All right. Okay. So that's the result. And then look at this question now. It says find the integral value of x. It's to solve this equation. Find the integral value of x. Now, what's the meaning of that question? Integral value means you need to find the value of x, but it has to be an integer. Like if you get a fraction or a decimal as an answer, don't list it along with the answers. Your answer should only be an integer. That's the meaning of this question. Basically, the question is to solve. Okay, so let's try this. Shlok, I'm going to copy this question, and can you suggest what should be the first step? Shlok.
So first we find the determinant of it.
Oh, you should find out the determinant. How would I find out the determinant here? AD minus BC. So tell
Cross
me.
multiply.
Yeah, cross multiply. Like that, I should cross multiply. So that's going to be 2x into x minus 2 minus -3 into 3x is minus 9x, isn't it? It's equal to 3. Do you all get that? It's AD minus BC. I cross multiply. When I do AD, I cross multiply like that. 2x into x minus 2, 2x into x minus 2 minus -3 into 3x is minus 9x. Subtract minus 9x is equal to 3. Then you open the bracket. So you'll get 2x squared minus 4x plus 9x is equal to 3. 2x squared plus 5x minus 3 is equal to 0. Yes, Reina. Purvika, what should I do next now?
Factorize.
Factorize. Can you? Okay, my product should be -6. Product is the first number multiplied by the last number, which is -6. And sum should be 5, the middle term. Sum should be the middle term, which is 5. So I'm looking for two numbers like that. Reina, what are the numbers?
So 6 and -1.
+6 and -1. Not 3 and 2. 3 and 2 doesn't work. because one has to be positive and one has to be negative. 3 and 2 doesn't work. It's only 6 and minus 1. 6 into minus 1 is minus 6, and 6 plus minus 1 is 5. So we split the middle term. 2x squared plus 6x minus 1x minus 3 is equal to 0. Then you have 2x common factor, so 2x into x plus 3 minus 1 into x plus 3 is equal to 0. You have x plus 3 common, into 2x minus 1 is equal to 0. Therefore, x is equal to minus 3 or x is equal to 1 by 2. But they want only an integral value, so x is equal to minus 3. They are asking for only the integral value. So we don't want the fractional answer there. X is equal to minus 3 and that's it. Everybody good? Okay. Question number 12 has two parts. We are going to try the B part of it. It's 12B. If you have finished that, you should start off. I give you 2 minutes to just go ahead of me and try. All of you should try now. Okay, so we have a determinant given to us. I copy the determinant, or rather the equation, and start expanding, which is first element is x squared, into its minor is 2, 1, 1, 4. Then second element, second position sign is minus. The element is x, into its minor. What's the element? What's the minor of x? Delete the row and the column it belongs to. 0, 1, 3, 4. 0, 1, 3, 4. Plus 1 into its minor. The minor of 1. Delete the row and the column it belongs to. So you get 0, 2, 3, 1 is equal to 28. Then you start expanding, so you'll get x squared into 8 minus 1 minus x into 0 minus 3 plus 1 into 0 minus 6 is equal to 28. So you get 7x squared plus 3x minus 6 minus 28 is equal to 0. I don't know, is the number that big? Are you getting like that? 7x squared plus 3x minus 34 is equal to 0. Did anyone get the numbers like that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So product is negative negative 34 into 7 and sum is 3. Need to try and figure that out. So that is 17 and 21. How did I get that? Actually, this 34 is 2, 17 and 14. 14. Okay, I think I should show detailed steps on it. This 34 can be written as 2 into 17. So 2 into 17 into 7. So you group 2 and 7 together. So 14 and 17. And you need plus 3. So plus and minus. Yeah, there you go. So those are the numbers. Minus 14 and plus 17 are the numbers. So I split the middle term. 7x squared minus 14x plus 17x minus 34 is equal to 0. 7x common factor into x minus 2 plus 17 into x minus 2 is equal to 0. I know most of you must have finished now. So x minus 2 common factor into 7x plus 17 is equal to 0. So you get x is equal to 2, which is your answer. The other one comes fraction, negative 17 by 7, and they don't want that. They said solve, find the integral value of x. So factorization obviously was a little bit difficult here. Yeah, you should handle it or use quadratic formula. Use quadratic formula. Everybody okay? Sahil finish?
Yes, sir.
Mera finish?
Yes, sir.
Okay. So now we have a small formula now. Okay. So look at this. We don't try to derive the formula because it is not exactly independently derived formula. If you remember last year's from coordinate geometry area of a triangle formula, when the three vertices are given as x1, y1, x2, y2, x3, y3, three vertices given. The area of the triangle is given by a long formula, if you remember, half into y1 into x2 minus x. If you remember that, right? It's the same thing. It's the same formula written in a determinant form. So someone just realized that, okay, this is actually the determinant evaluation. So it's not independently proved or something. If you look at that formula which you have derived last year under coordinate geometry, you can see that it's exactly same as the expansion of this determinant. So you just have to memorize this formula, this format, that's it. It's not an independent formula. So if x1, y1, x2, y2, x3, y3 are the vertices of a triangle, then its area is given by the formula half into determinant. Now, how do I remember this formula? x1, y1, the first vertex followed by 1. x2, y2, the second vertex followed by 1. Then x3, y3, the third vertex followed by 1. It's pretty simple. Half into x1, y1, 1, x2, y2, 1, x3, y3, 1. First vertex followed by 1, second vertex followed by 1, and the third vertex followed by 1. That's the area of a triangle using the determinant method when the three vertices are given to us. So let's do a question on it. We are going to do question number A from there. Copy down the formula first and then we do question A. Question A, the three vertices I will copy: minus 3, 5, 3 minus 6, and 7, 2. And I call it as x1, y1, x2, y2, and x3, y3. Call the points as x1, y1, x2, y2, x3, y3. And then we have the area formula. Area is equal to area of the triangle is equal to half determinant area of the corresponding triangle. It's half determinant x1, y1 followed by 1, x2, y2 followed by 1, x3, y3 followed by 1, which is equal to half determinant x1, y1, minus 3, 5, and 1, 3 minus 6 and 1, then you have 7, 2, and 1. Then you start expanding. It's just normal determinant expansion now for you. Should be able to do that. It's half into, go ahead and expand all of you, and you will get the answer. Just do it, expand it. Half into, we start expanding. The first element is position sign is plus, but the element is -3 into its minor. This time I'm going to just visualize the minor. That's my minor. So I will cross multiply, which is -6 minus 2. -6 minus 2. Minus, the next element is 5 into its minor. I will just visualize the minor. The minor of it is, this is the element, delete the row and the column it contains, cross multiply 3 into 1, 3 minus 7. So I'll get 3 minus 7. Yes, some of you finished. Plus 3, the third element is 1 into its minor. And I'm not writing the minor, I'm going to just visualize the minor. That is the element gone. When I cross multiply, I'll get 6 minus 42. 6 minus 42. Close the bracket, which is half into -3 into -8 minus 5 into -4 plus 1 into 48. That gives me half into 24 plus 20 plus 48. That's half into 24 plus 20, 44, 88, 92. So is it 46 square units? Is that what you all got? 46.
Yes, sir.
Yes.
Okay, so let's go to the next question. The question here is to find out the area of a parallelogram when 3 vertices are given to you. Can anyone suggest a method? I have drawn the diagram. What should I do there? Question is to find out the area of the parallelogram. What should I do here?
So first, note down the vertices and then find the determinant. Put it in the area formula.
So you will get the area of the triangle. And then how do I make the area of the parallelogram?
Just double it.
Double it. Come on, guys, you should do it. Find the area of the triangle ABC and then double it to get the area of the parallelogram. Go ahead. So I'm going to find out the area of the triangle first. Area of triangle is half determinant x1, y1, 1, x2, y2, 1, and x3, y3, 1. That's half into determinant x1, y1, 1. 2, -7 and 1. Then 1, 3 and 1. Then 10, 8 and 1. Which is equal to half into, start expanding. 2 into its minor. I'm trying to visualize my minor. 2 is the element, delete the row and the column, cross multiply 3 into 1, which is 3 minus 8 minus, the next element is minus 7, yes, into its minor. So I know the element minus 7, delete the row and the column it belongs to, cross multiply the remaining, 1 into 1 minus 10. So I'll get 1 minus 10 plus 1 into its minor. That's the element 1. Delete the row and the column it contains, cross multiply. You will get 8 minus 30. So now evaluate it and then double the answer to get the parallelogram area. So that's going to be half into 2 times negative 5 plus 7 times minus 9 plus 1 time minus 21. Oh, there is one thing I forgot to actually tell you. When you apply this formula and do it, sometimes your answer can turn out to be negative. You should know that the area cannot be negative, so you will take the absolute value of it. Okay, make it into positive. So half into negative 10 minus, oh, like in this case, it is going to be a negative answer. That's negative 63, negative 21. So half into negative 94. So that is going to be negative 37. I don't know if I made a mistake. Did anyone get like
74.
that?
Minus 74.
Where is 74?
Yes, yes, sir. Correct.
That is 94.
It's correct, right?
Yes, sir.
Okay.
So isn't my 8 minus 30 minus 22?
It is minus 22, right?
Ah, okay. I see. I see my mistake. So that's going to be negative 22. So that will give me half into negative
95.
95. Okay, so I'll say area is equal to 95 by 2 square units for the triangle. Therefore, area of the parallelogram. Area of the parallelogram will be double of it, 95 square units. Or in the beginning itself, I could skip the half and write the formula, right? If it is a parallelogram, just skip the half in the formula, that's it. Everybody is okay? So if it is a parallelogram, you find the area of the triangle and double it. Vedant, finish?
Sir, I'm getting some other answer. I did across the third column.
You did what?
I took the third column 1, 1, and then I did the determinant of that. And I'm getting some other answer.
Can you read out that first determinant you have written horizontally?
It will be 1, 2 minus 7, 1, 3.
1, 2 minus 7.
1, 3.
Just the first row you read.
So 1 in, and then determinant will be 2 minus 7, 1, 3.
No, hold on.
Okay.
So you don't have a determinant written. You already started expanding.
Yes, sir.
The very first step. That's what I don't understand. How do you start that? One, which. So your B is taken as the first point, probably. That's the meaning, right?
Sir, like, okay, so I took the third column for like because it's 1, 1, 1.
For
Yeah.
expanding. For
Yes, sir.
expanding. Yeah, okay. So 1 into
1 into 2 minus 7, 1, 3. That is the determinant.
okay. Then
minus 1 into 2 minus 7, 10, 8
Okay, that's correct.
plus 1 into 1, 3, 10, 8.
Okay. So the first one should give you 1 into 6 minus
Yes,
minus
sir.
7, right? Okay. The next one should give me minus 1 into 16 plus 70.
Yes, sir.
Did you get like that?
Yes, I
16 plus
got the
70.
same value.
And the next one is plus 1 into, should
Minus
get 8
22.
minus 30,
Yes.
minus 22. So it's
No,
not working
sir.
out to be 95. 1 into 6 plus 7 is 13. So if I write it 1 into, you are getting 6 plus 7, which is 13, minus 1 into 16 plus 70, 86. Is that 86 you are getting?
Yes, sir. Minus 86.
And plus 1 into 6 plus 7. That is 13. So that is 13.
Oh, sir, I got my mistake. I did some calculation error.
Okay.
Thank you, sir.
Yeah, I didn't help you anyway. Yeah. Okay. So let's go to another one. Okay. So this question here, look at this question. It says find K if these 3 points are collinear. So they have given you 3 points and they say they are collinear. So what the best thing to do here is draw a line and mark these 3 points on it because they are collinear. So we're going to draw a line and mark these points on it. These are given to be 3 collinear points. So let's do that. Draw a line first. We have a line drawn and mark the 3 points on it. And whenever I do this marking the 3 points, I prefer to mark the unknown point as my first point. It's up to you, but it's a tip. It makes your calculation easier. So the unknown point I'm going to take as my first point. Unknown point is minus k plus 1, 3k. That's the unknown point. Then B and C in any order you like. That's my B. This is my C. So look at that. That's a small tip. It simplifies your working. Okay. So what is it? The unknown point I marked first as my A, then I have my B, then I have my C. These 3 points are marked on the same line because they are collinear. Now, if the 3 points are on the same line, can we make some connection between this and what we just learned, the area of a triangle? Can we figure out some relation here? Anyone? Vedant, if you are still there, can we make any connection between what we have been doing with the area of the triangle and this situation
So
here?
we would say that the area of a triangle would be 0. So
Exactly. We can say that
it
area of
is
the
equal
triangle
to
is 0.
a half into mod of determinant
Is
is
equal
equal
to
to
0.
0.
And then solve for k. That's it. Come on, go ahead. Since the 3 points are collinear, area of the triangle has to be equal to 0. So I'm going to write that. Since the points are collinear, area of triangle ABC has to be equal to 0. Area of the triangle ABC has to be equal to 0. That's half determinant x1 y1 1, x2 y2 1, and x3 y3 1 is equal to 0. half determinant x1, y1, 1, x2, y2, 1, x3, y3, 1 is equal to 0. Purvika, don't try to expand with 1, 1, 1 this time because it's harder going to be for you.
Okay,
You
sir.
should definitely evaluate with the first row because you have the unknowns then set outside. That makes your calculation so much easier than anything else you would do here. All right, the first thing is I'm going to multiply both sides by 2. So this half disappears from the left-hand side. I don't have the half. I'm not forgetting to copy it. It's not existing anymore. I multiply both sides by half. So determinant x1, y1, 1, the first point, unknown point first, minus k plus 1, 3k and 1. The second point, I don't really worry about it, any one of the points. And the third point, minus 3, 8 and 1 is equal to 0. So 2 is gone because we cross multiplied 2 to the other side or multiplied both sides by 2. Then I'm going to expand. Normal expansion. Minus k plus 1 is my first element into its minor. Minor you can either write or you can do it in your head. If you are able to do it in your head, you do it or show the minor. The minor is 4181. Minus, the second element is, second position is minus. The element is 3k into its minor. So for the element 3k, the minor is delete the row and the column, 4 elements remaining. So that's going to be minus 1, 1, minus 3 and 1. Plus 1 into Tarun, 1 into its minor. Delete the row and the column it contains, the 4 elements. So you'll get minus 1, 4, minus 3 and 8 is equal to 0. Then when you start expanding, minus k plus 1 into 4 minus 8. I'm trying to do it in my head now. 4 minus 8 is minus 4. Minus 3k into minus 1 plus 3 is 2 plus 1 into minus 8 minus minus 12 is 4. I skipped a step. Open the bracket, 4k minus 4 minus 6k plus 4 is equal to 0, which implies minus 2k is equal to 0. Therefore, k is equal to 0 divided by negative 2 is equal to, it's not addition, it's division, minus 2 into k. These are, one could make a careless mistake. Minus 2 move to the other side and it becomes plus 2 kind of a thing, which is wrong. It's negative 2 into k is equal to 0. So if I want to get rid of that multiplication, I should divide both sides by negative 2. So k is 0 by negative 2, which is 0. So you get k is equal to 0. Okay. Everybody finish this? We're going to go and do another one, question number 17 next. Question number 17 next, if we have finished this. Everybody finish? Anyone needs help with any of
Finish, sir.
Aishi, what did you say? You finished or?
I said done, sir.
Oh, okay. Excellent. Very good. We move on to question number 17. Question number 17. But I need to tell you something in this question before you start with it. Okay? Look at this question, all of you. And then you can go ahead and do it. If you look at this question 17 here, it says, find x if the area of the triangle is 35 square units. Your first statement is area. Okay? Area is equal to 35. And then I write the formula for area. I'm going to write that now. Okay? So when I write that formula, Shlok, can you tell me the formula? Half determinant?
Half x1,
Y1, x1, y1,
1.
1.
Then x2, y2, 1.
Okay, and x3,
y3, 1.
y3, 1. Determinant should be equal to what?
It should be equal to the 35 area.
Yeah, it should be equal to 35. Can anyone make a small addition to this? It should definitely be equal to 35. Can anyone make a small addition to this? Like this statement is not wrong, it's correct, but it can be a better answer there.
So plus or minus 35.
Yes, Humaira, it can be plus or minus 35 because we saw in one question, when you do the determinant doesn't have to be always positive. Determinant can be negative. So when I use the determinant to find the area of the triangle, it could also give me negative 35 as my answer. But I will say area is 35. So that's how they told us that the area is 35. It doesn't mean that the determinant gave them 35 as the answer. The determinant could have given them negative 35. Still, they will say area of the triangle is 35. So I should know that when I equate the determinant with the given answer, it's not just 35. It could be plus or minus 35. Very important point. Next step, I'm going to multiply both sides by 2 and also sub in the value. And I will make sure that I keep the unknown point as my first row. Multiply by 2. Therefore, determinant unknown point in the first row, x 4 and 1, x 4 and 1, 2 minus 6 and 1, 5, 4 and 1 is equal to plus or minus 70. Plus or minus 70. And then I start expanding. So when I expand, I'll get x into its minor, minus 6, 1, 4 and 1, minus 4 into its minor, 2, 1, 5 and 1, plus 1 into its minor, 2 minus 6, 5 and 4 is equal to plus or minus 70. So that is x into minus 6 minus 4. Yes, Raina. Minus 4 into 2 minus 5 plus 1 into 8 plus 30 is equal to plus or minus 70. Minus 10x plus 12 plus 38 is equal to plus or minus 70. Minus 10x plus 50 is equal to 70, or minus 10x plus 50 is equal to minus 70. Yes, that one. Minus 10x is equal to 20, so x is equal to minus 2, or minus 10x is equal to minus 120, x is equal to 12. Is that what all of you got?
Yes, sir.
Yeah. If anybody is still writing, wait for another 1 minute. Sahil,
Yes, sir.
you understand?
Yes, yes, I understand.
You finish writing?
Yes, sir.
Anyone still writing? Neha, finish?
Yes, sir.
Okay. Pranavi, finish? Pranavi?
Yes, sir.
Okay. Can you all try this 18 yourself quickly? Question 18. Question number 18. There is this area given to you. Area is 30.5, but when you put it into determinant, put with the formula half determinant x1, y1 and 1, x2, y2 and 1, x3, y3 and 1. The answer is plus or minus 30.5. We'll multiply both sides by 2 and sub in the values. I'm going to pick up the unknown point and put it in the first row. It makes a lot of difference when you actually do it. So minus 4k is only if you expand using the first row. Don't get carried away by looking at 1, 1, 1. So minus 4k and 1, 3, 8 and 1, 5, 0 and 1. Is equal to plus or minus 30.5 into 2. I cross multiplied 2. So negative 4 into its minor, 8 minus 0. I'm skipping the minor. I'm doing it directly. Minus k into its minor. I can visualize the minor. Minor of k will be these 4 numbers. So I cross is that. When I cross multiply, I will get 3 minus 5 plus 1 into its minor. That's the element. Delete the row and the column. Cross multiply 0 minus 40. Is equal to plus or minus 761. Yes, Raina. Yes, Aishi. So negative 32 plus 2k minus 40 is equal to plus or minus 61. So 2k minus 72 is equal to plus or minus 61. Make it into 2 cases. 2k minus 72 is equal to 61. Or 2k minus 72 is equal to minus 61. 2k is equal to 61 plus 72. Or 2k is equal to minus 61 plus 72. It's Sahil. Sahil, is that what you got, Sahil?
Yes, sir.
Okay. Everybody finish that? Can we move ahead? If you all have finished. Mera finished writing?
Yes, sir.
Okay. Okay, this question is slightly different kind of a question. Question number 21 there. Look at the question. What are they asking for? Find the equation of a line passing through 2 points using determinants. Actually, this is something which we have done under coordinate geometry last year. They give you 2 points and then they ask you to find out the equation of a line. We use the 2-point form of a line. We know how to do it in one line. Write the formula, 2-point form of a line. Y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. And you get your answer. But that is not the question here. The question is still the same. Find the equation of a line. But the method, they want it to be done using the idea of determinants. So let's draw a diagram. This is question number 21. Put a rough diagram, draw a line, and mark the given 2 points on it. Okay? So that's the first thing you're going to do. You have a line, mark 2 points on it. Okay, you should mark like the way I'm doing. Put them up there. call them as something. Okay, 1 and 2 is the first point, minus 2 and 3 is the next point. And then you mark, since you need to find out the equation of a line. Equation of a line means an equation which is being satisfied by every single point on that line. That's the meaning. Equation of a line means an equation which is satisfied by every single point on that line. So I'm going to mark a general point P called x comma y on this line. So I have this line which is passing through the two given points. I marked them already on it, 1 comma 2 and minus 2 comma 3. And it should be satisfied by any general point on the line. So I marked a general point. That's why it is x comma y, px comma y. So now that I mark 3 points on this line, I can say the 3 points are collinear. The 3 points are collinear. So we come down to the same idea. 3 points are collinear. Nahad, what do I say then?
So therefore, the area of the triangle formed by these vertices is 0.
Area is equal to 0, equated to 0, and you will get a relation connecting x and y, and that is going to be the equation of the line. Come on, go ahead and do it. Area of the triangle formed by the 3 points will be equal to 0. Go ahead, do it. Area of the area of the triangle formed by the 3 points is equal to 0. Area of triangle is equal to 0. So half determinant x1, y1, 1. I'm going to skip the formula this time. X, y, and 1, 1, 2, and 1, minus 2, 3, and 1 is equal to 0. I multiply both sides by 2, so 2 is gone. So x into determinant 2, 1, 3, 1 minus y into 1, 1 minus 2, 1 plus 1 into 1, 2 minus 2, 3 is equal to 0. So x into 2 minus 3 minus y into 1 plus 2 plus 1 into 3 plus 4 is equal to 0. Minus x minus 3y plus 7 is equal to 0. Okay. What's the equation you got? Is it the same?
Yes, sir.
Pranavi, did you get the same answer?
Yes, sir.
Okay. Everybody finish? Neha?
Yes, sir. Done.
Okay. Okay, so there is one more question on that for homework. We move on to the next idea, which is called the adjoint of a matrix. Or maybe we can find the adjoint and hence and also find a inverse. Okay, adjoint step by step, you will know the method. You might be doing even directly into the matrix. I like to do the individual elements and then calculate it so that less possibilities of making mistakes. So I'm going to go and do it in a detailed way. There is a small definition before we go on to that actually. Adjoint of a matrix. Adjoint of a matrix is adjoint. This is how you write it. Adj of a. Adjoint of a matrix is the transpose. Is the transpose of the corresponding cofactor matrix. Cofactor matrix. Adjoint of a matrix A is the transpose of the corresponding cofactor matrix. Now, what is cofactor matrix? A cofactor matrix is a matrix obtained by replacing every individual element by its corresponding cofactor. And what is cofactor? Cofactor is a signed minor. You know, the terminology is so confusing, I know. But when you start doing it, it'll be fine. So what I talked about is only adjoint. Adjoint is the transpose of a cofactor matrix. Now, what is a cofactor matrix? You find out individual cofactors and make a matrix, and that's called a cofactor matrix. Now, what is cofactor? Cofactor is signed minor. Minor with the position sign is called a cofactor. Signed minor is called a cofactor. So let's do a question, then you will understand it. So you have this matrix A given to us. 57 is what we are going to do. So the first thing is I need to find out the cofactors. Cofactors are denoted by capital letter A, uppercase A, 1, 1, A, 1, 2, A, 1, 3, like that. So maybe you should see how I do it. A, 1, 1. I write A, 1, 1. This is the cofactor of the first row, first column element. A, 1, 1. Now you should watch this. A, 1, 1 will be minus 1 to the power of 1 plus 1, which is the position sign. But we know it is minus, yeah? So it's actually minus 1 to the power of 1 plus 1, which is minus the first position. It goes like this. It's plus here, minus 1 to the power of 1 plus 1. The next position is minus, the next position is plus, then minus, then plus, then minus, then plus, then minus, then plus. So you can see, as somebody was telling the other day, diagonally they will always be positive, yeah? So it's like plus minus plus, minus plus minus, plus minus plus. It goes like that. But the rule is minus 1 to the power of I plus j. So I have a plus sign first. I was going to write minus, I don't know, for some reason. Oh, I was going to write minus 1 to the power of 1 plus 1, which makes it plus. So plus of its minor. What's the minor of this element? This is the element. Delete the row and the column it contains, cross multiply. 3 into 1 is 3 minus 0. So you know how you evaluate a determinant. The difference is we don't pick up the element. It's plus of 3 minus 0. Only the minor. See, it's the position sign with the minor is called a cofactor. Plus of the minor. So it is 3. Then you will write A12. I need to have A11, A12, A13 in the first row. Like how you write a matrix. A12 would be minus of. The second position is always minus. That's the position. Delete the row and the column it contains, cross multiply. When I cross multiply, I'll get 2 into 1 is 2 minus minus 10. So 2 minus minus 10, which is going to be 12. So minus 12. That's A12. Now I have A13. And what is A13? Plus of. A13 is plus of. A13 is here. Plus of. Delete the row and the column it contains. You see, you don't pick up the element, only the position sign. Then delete the row and the column it contains, cross multiply. You will get 2 into 0 is 0 minus minus 6. 0 minus minus 6, which is going to be 6. That's just the first row. Now I go to the next row, which is A21. And A21, when I say it's plus, minus, and plus, So now it is minus. So it's minus of its minor. Now, how do I find out the minor of this element? Look at this. That's the element I'm talking about, A21. This is the element I'm talking about. I don't take the element. I take only the minor. So delete the row and the column it contains. Cross multiply. 1 into minus 1 is minus 1, minus 0, minus 1, minus 0, which is going to give me 1. Okay. Now, A12, when I say the position sign will now be plus. Look at that. For this position sign is plus. Delete the row and the column it belongs to. Do you see the 4 elements remaining? That is called its minor. So I'm talking about the minor of A21, A22. So A22 is this element. Delete the row and the column it contains. The remaining 4 elements I should cross multiply. So Aishi, can you tell me what is the minor of this element A12 plus of Aishi?
So it's 1
1 minus
minus of minus 4.
minus 4.
It will be plus
1
4.
minus 4. That's 5 there. Then A13, when I say, Rainer, tell me the position sign for this element. Plus of.
Yes, sir.
Rainer. Plus of, what's the element going to be?
5.
It's 0 minus 4. Yeah, it's Rainer. I'm finding the cofactor of A13. The cofactor of A13 means cofactor corresponding to 5, which is plus of, plus, because the position there is plus now. Now we don't pick up the element, we only write the minor. The minor of 5 is 1 into 0 is 0 minus 2. Then it's plus of, it's plus or minus, I'm sorry. What is it supposed to be?
It's a minus.
It's minus because this was minus, then plus, and now this is minus. Okay, minus of, this is the element, delete the row and the column it contains, cross multiply 0 minus 2.
So,
minus 2, yes.
so won't it be 822 and 823?
I don't know, I wrote them wrong. Okay, I wrote even this wrong. It's 2, 2 and 2, 3. Yeah. The next one will be A31. A31 will be position sign is plus. Position sign is plus. You know how it goes. It's always plus, minus, plus, minus, plus. Maybe you should keep that ready there. Then there is no confusion. This is plus, the next is minus, the next is plus. Let me do that. This is A32. That's why I made mistake. This is minus. This is A33, which is plus. I think I should do that first and keep like this. A11 plus A12 minus A13 plus A21 minus A22 plus A23 minus. Then A31 plus A32 minus and A33 plus. I think I should do this much first and then start writing the numbers.
Sir,
Okay. Yeah.
wouldn't 823 be minus 2?
Let's do it again. It's minus here, then the minor of that element. I put a minus sign, then the minor of this element. Delete the row and the column, cross multiply, and you tell me what do I get inside?
It will be 0 minus of minus 2.
No, 0 minus 2 only.
Okay, sir. Yeah. Right.
Because minus 1 into minus 2 is 2. So minus and minus will make it plus 2. That's correct actually.
Okay, sir.
The next one, A31, when you say this is the element. So delete the row and the column it contains, cross multiply, you will get negative 5 minus 6. Do you see that? Negative 5 minus 6. Minus 5 minus 6, which is going to be minus 11. Then A32 will be 32. This is the element. delete the row and the column. Cross multiply 1 into 5 is 5 minus 4, which is minus 1 now. A33 plus of, that's the element, delete the row and the column it contains, cross multiply 1 into 3 is 3 minus 2, which is 5. They ask for adjoint. Now, this is called cofactor. Adjoint will be the transpose of the cofactor. What you have written is called cofactor. You should take the transpose of it. So read the first row, but write as the first column. Read the second row, write as the second column. Read the third row, write as the third column. Do you see what I'm saying? So the adjoint of A would be, read the first row, write as the first column, which means 3 minus 12 and 6. That's the first row, written as the first column. Now read the second row, write as the second column, because adjoint is transpose of the cofactor. Read the third row, write as the third column, minus 11, minus 1 and 5. Read each row and write as the corresponding column. That's adjoint of A. Just see if you are able to do the adjoint. Then we'll talk about the inverse. Anybody confused somewhere? If you can tell me, then I can go over that. Maybe in school you are directly writing it into a matrix straight away. But I think cofactor can be written separately. Like if you make a mistake, it's easier to go back and check. Are you guys okay with this? Sahil, what do you think? Manageable?
Yes, sir, manageable.
Okay. Now the next part of the question is asking for A inverse. For A inverse, we have a formula. A inverse is 1 by determinant A into adjoint of A. We already have our adjoint of A with us. Then you just have to do 1 by determinant A times adjoint of A to find out our A inverse. We know what is A inverse. We have discussed about it before. So this is the formula for A inverse. 1 by determinant A into adjoint of A. I have already adjoint of A. I just have to find out determinant A and divide. So I'm going to do determinant A. Determinant of A. 1 minus 1, 2. 2, 3, 5. Minus 2, 0 and 1. I need to evaluate this determinant. So 1 into 3 minus 0 minus 1 into determinant. Now all of you know how to do it. Just expand. Minus 1 into 2 minus 10. I'm skipping the minus now. I can do it in my head. If anyone needs to write the minor, please do it. 0 minus 6, which is going to be 3 plus 1 into 12 plus 2 into 6. So that's going to be 12, 24, 27. Determinant A is 27. Therefore, A inverse is 1 by determinant A into adjoint of A. 1 by 27 into adjoint of A. We already have up there, copy it. And that's my answer. Now, do we take this 1 by 27 inside and divide each one by 27? It's up to you. You could leave it like that. or you could divide each term by 27. Look, all of them fractions, so I'm leaving it here. That's my A inverse. Tell me if you have trouble, or what we could do is we will do one more question like this carefully, slowly, and then listen to me and do it with me. It should be fine. So that's your A inverse. I don't finish. If you finish, you tell me. We will try another question. Shall I finish?
Yes, sir. Done.
Okay, so we're going to try another question to find out the inverse. Okay. Let's do this 59. It also says only adjoint. I'm going to say find the adjoint. Instead of that, I'll make it find the inverse. Find the inverse. Now, you know that to find out the inverse, the formula is just one quick result on it. To find out the inverse of A, it's 1 by determinant A into adjoint of A. So we know that we need determinant. I'm just saying one quick thing. Just okay. Sorry. Okay. All right. Yeah, I was trying to tell you this result. Like, it is a good idea to find out determinant A first. Because just in case your determinant turns out to be 0, suppose it is 0, then you don't have to go ahead and do this, because we know we will end up dividing by 0, and division by 0 is not possible. So why should we spend so much time finding all these cofactors? Do you understand what I'm saying? Just thinking about that possibility. Like, in case your determinant A turns out to be 0, I will end up dividing by 0. Then why am I wasting so much of time? Division by 0 is not possible. So it's a good idea to, in this kind of a question, when they ask you to find out the inverse, first find out determinant A. If determinant A is 0, it's called a singular matrix. We will say it's a singular matrix, and hence it doesn't have an inverse. Stop the question there. Okay, so let's take that chance and see. In case, hopefully, if it is 0, our job is done. If it is not 0, we'll go ahead and find the cofactors. then the adjoint, and then the inverse. So I'm going to do determinant A first before adjoint. Determinant A. Determinant -2, -3, 2, 3, 4, 5, -2, -3, 4. That's determinant A. And then you start expanding. So when you expand, it's first element, -2 into its minor. Determinant expansion. Its minor is 4, 5, -3, 4. You can do it in your head. Minus, the second element is -3 into its minor. 3, 5, -2, 4. Plus 2 into its minor. 3, 4, -2, -3. Then you start expanding. -2 into, when you cross multiply, 16 minus -15 plus 3 into cross multiply 12 minus -10 plus 2 into cross multiply -9 minus -8. So -2 into, that's going to be 21, 31 plus 3 into 22 plus 2 into -1. So -62 plus 66 minus 2. So I think it is just 2. Did you get determinant A as just 2 there? Yeah?
Yes, sir.
Okay. So it's just 2 there, and then we go for the adjoint. To find out the adjoint, I'm doing individual cofactors. A11 will be plus of, A12 will be minus of, I need to space it out actually. A13 will be plus of. Maybe I move it a bit this side. Okay. So then I go to A21. A21 will be minus, because I ended with plus, now it should be minus. Then A22 should be plus of. Then A23 should be minus of. A31 will be plus of. A32 will be minus of. And A33 will be plus of. And I put the values into this. I evaluate it. Minor for each of them. A11 is here, it's minor. I try to visualize like that. A11, when I say, I delete the row and the column it belongs to. The rest, when you cross multiply, it is 16 minus 15. 16 minus 15, which is 31. Now, A12, when I say this is the element A12, delete the row and the column it belongs to, cross multiply. That's 12 minus 10. 12 minus 10, which is minus 22. And A13 will be, that's the element, delete the row and the column it belongs to, cross multiply. We get minus 9 minus 8. Which is minus 1. Now A21, that's the position. Delete the row and the column it belongs to. Cross multiply. Negative 12 minus 6. Negative 12 minus 6. Which is going to finally give me 6. the next element A22, that's the element A22, delete the row and the column it belongs to, cross multiply, -8 minus -4. Which is going to be -4. Then A23 will be delete the row and the column it belongs to, cross multiply, we'll get 6 minus 6 again. 6 minus 6, which is going to be 0. I just want to check that element again. This is A23. A23 is out here, A23. So I delete that row and that column. The remaining, when I cross multiply, it is 6 minus, then 6 again, 0. No, A31, it's plus, I already know. So A31 is out here, A31. Delete the row and the column it belongs to. Then you cross multiply, you will get -15 minus 8. -15 minus 8, which is -23. Then A32, this is the element A32. I delete the row and the column it belongs to. Cross multiply, -10 minus 6. -10 minus 6, which gives me 16. Then A33. A33 is, this is the element A33. Delete the row and the column it belongs to. Cross multiply, you will get -8 minus -9. One more time. We are looking for A33. So for A33, this is the position A33. I delete the row and the column it belongs to. Cross multiply, -8 minus -9. -8 minus -9 makes it plus there. So it's equal to 1. So I have every element done. So I'm going to do A inverse straight away. I'm not writing adjoint. I'm straight away doing A inverse. A inverse is 1 by determinant A into adjoint of A. 1 by determinant of A, 1 by 2 into adjoint of A. Adjoint of A is the transpose of the cofactor. So I take the transpose of the cofactor, read the first row, write as the first column. So read the first row, 31 minus 22 and -1. Read the first row and write as the first column. Now read the second row and write as the second column. So that is 6 -4, 0. So that's very important. You are reading the first row, copying it as the first column. You are reading the second row, copying it as the second column. Then read the third row and copy as the third column. That's -23, 16, and 1. That's my A inverse. Look at that, see if you got every single element correct.
This one you don't need.
Okay, did you all get that right? Anyone has any of the element wrong? You should tell me. Everybody finish?
Yes, sir.
Okay. All right, now we have a question here. That's now we have the application questions. The first one is kind of, we don't have much of applications. Area we already saw. Collinearity we already saw. The next is solving equations. That's it. That's the last application. So then it will be over. So the question is to solve this matrix equation. I'm sorry, the system of equations using matrix method. Solve the given system of equations using matrix method. So what we are going to do is, we have this equation given to us. When you read the question, make sure that your x, y, z are in that order. What I'm trying to say is that, like, someone could write this equation like minus y plus 2x is equal to 2 minus z, something like that. They could play around with the order. But what you need to do is make sure that the equations are always written in the correct order, like x, y, z, and then the constant, which is on the right side. So that I am going to check if it is that way. Yeah, x, y, z and constant, x, y, z and constant, x, y, z and constant. The next, we form the corresponding matrix equation. Now, what do you mean by corresponding matrix equation? I list out the coefficients as x, y, z. Like, look at the first one. The coefficients of x, y, and z are 1, 1, and 1. So I will write 1, 1, and 1 and close the matrix. That's for the first equation. Then for the second equation, if you look at the coefficients are 2 minus 1 and 1. So I will write 2 minus 1 and 1. And for the third equation, if you look at the coefficients, it's 1 minus 2 and 3. So I'll write 1 minus 2 and 3 into, then you write the the variables. The variables are x, y, and z. You should write that. The variables are x, y, and z is equal to, you look at the variables, we write x, y, z, but vertically as a column matrix. That's because the matrices should be compatible for multiplication. And the constant matrix, the right hand side, 1, 2, and 2. Look at that. How did we do that again? So you look at the first equation, coefficients are 1, 1, 1. Second equation, 2, 1, minus 1. And the third equation, 1, minus 2, 3. I wrote it like that. That's a coefficient matrix. Then I write the variable matrix, which is x, y, z. And then the constant matrix on the other side is 1, 2, and 2. Is that okay? Then we name this matrix, the first matrix as A, the variable matrix as X, and the right-hand side matrix as B. And then to get rid of X, because we are trying to solve for X, Y, Z, that is the matrix X. We are trying to solve for X. So if I want to find out X from here, I should move A to the other side. A should go and divide, we usually say. But in matrices, we say it becomes A inverse. It's called pre-multiplying. Pre-multiplying by A inverse. So you will pre-multiply by A inverse. If I pre-multiply by A inverse, on the left side, this A inverse and A will get cancelled, giving me only X. But on the right side, it will stay as A inverse into B and leave it as equation number 1. Look at that again. I pre-multiply by A inverse, so A inverse and A will cancel. But on the right side, it will be A inverse into B. I put an A inverse on the left side of both the sides. A inverse into the LHS and A inverse into the RHS. So I get X is equal to A inverse into B. Now, once you have this A inverse into B, I'm leaving it here because I don't know what A inverse is. So I'm going to go and find A inverse now. So I'll do A inverse. For that, first I need determinant A. So determinant A is determinant 1, 1, 1, 2 minus 1, 1, 1 minus 2, 3. And then you should start expanding. So 1 into, start expanding. Minus 3 minus 2. Minus, the second position sign is minus. 1 into, that's the element, delete the row and column, cross multiply 6 minus 1. Plus 1 into, it's minor. That's the element, delete the row and the column, cross multiply minus 4 minus 1. which is equal to minus 3 plus 2 is minus 1. Minus 1 into 5 plus 1 into minus 3, which is going to be minus 9, I think. Did anyone get negative 9 their determinant?
Yes, sir.
Okay. Now I need the cofactor, so I'm going for cofactor now. So cofactor, I'm going to list out the signs first. A11 will be plus of something. A12 will be minus of something. And A13 will be plus of something. Always make sure that you will be able to fit in all the three in one line. Then A21 will be minus. A22 will be plus because alternate plus minus. Then A23 will be minus. A31 will be plus. A32 will be minus. A33 will be plus. Now I am going to evaluate it. So for this element, ignore the element, delete the row and the column, cross multiply. Minus 3 minus minus 2. It's going to be minus 1. Now for A12, this is the element, delete the row and the column it contains, cross multiply. 2 into 3, 6, 6 minus 1. So it's minus 5. Then A13, that's the element, delete the row and the column, cross multiply. Minus 4 minus minus 1. It's negative 3. The next row, A21. A21 is here. Delete the row and the column it contains, cross multiply. So you will get, so that's the element A21. Delete the row and the column, cross multiply. 1 into 3 is 3 minus minus 2. 3 minus minus 2. Which is going to be negative 5. The next is plus of, this is A22. Delete the row and the column it contains, cross multiply. 1 into 3, 3 minus 1. Which is going to be 2. Then A23, that's the element A23. Delete the row and the column it contains, cross multiply. Minus 2 minus 1. Which is 3. Now A31, this is the element A31, delete the row and the column it contains, cross multiply. You will get 1 minus minus 1, which is 2. Then A32, this is the element, delete the row and the column it contains, cross multiply. 1 minus 2, which is 1. Now A33, that's the element, delete the row and the column it contains, cross multiply. Minus 1 minus 2, which is minus 3. Okay, so I finish all the cofactors, and so now I'm going to do my A inverse straight away. A inverse is 1 by determinant A into adjoint of A. 1 by determinant A is minus 9 into adjoint of A. Adjoint of A is transpose of the cofactor. Look at that, transpose it is, don't forget it. Minus 1, minus 5, minus 3. Take the first row and write as the first column. Second row and write as the second column. Third row and write as the third column. And don't do anything, just leave it like that. That's A inverse. Now you should go back to equation number 1. Equation number 1 says x is equal to A inverse into B. X is equal to A inverse into B. X is x, y, z is equal to A inverse is minus 1 by 9 minus 1 by 9 into minus 1 minus 5 2 minus 5 2 1 minus 3 3 minus 3 into B. What is B? Go back and see what is B. 1 2 2 1 2 2. Do you understand this step, what I am doing? I copied my equation number 1, which is x is equal to A inverse into B. That's my equation number 1, x is equal to A inverse into B, where x is what? X, Y, Z is equal to A inverse is what? I just found out. And what is B? B is 1, 2, 2. So that's what I did here. I put all the values into that equation. Now, keeping this minus 1 by 9 outside, I will just do normal matrix multiplication. And how do I do matrix multiplication? The row goes with the column. The row goes with the column, but keep minus 1 by 9 outside only. Do not take it inside. So minus 1 by 9 into, the row goes with the column. Minus 1 into 1 is minus 1. Minus 5 into 2 is minus 10. Plus 2 into 2 is 4. That's first row into the first column. Then the second row into the first column. Minus, see how you do that? Now this second row into the first column. Then third row into the first column. So it's going to be minus 5 into 1 is minus 5. Plus 2 into 2 is 4. Plus 1 into 2 is 2. And then again, third row into the first column. Minus 3 plus 6 minus 6. So do we get minus 1 by 9 into minus 7, 1 and minus 3. Then in the last step, you will take this minus 1 by 9 inside. So I'll get 7 by 9 minus 1 by 9 and 3 by 9. That's it. So I have my solution. So I compare the two matrices from left side and right side. So I'll get x is equal to 7 by 9, y is equal to minus 1 by 9, and z is equal to 3 by 9, or rather 1 by 3. So I have the solution, x, y, and z. That's the solution. How many of you got this answer? Nahar?
Yes, I got the same answer.
Arun?
Yes, sir, I do got.
Okay. Shlok, did you get or are you still working on?
Yes, sir, done.
Done.
Sir, could you explain that pre-multiplying that step once?
Okay, pre-multiplying because your A is on the left side, right?
Yes, sir.
So A is written on the left side of X here. If that has to go, your A inverse should appear on the left side on both sides. So that A inverse and A will get cancelled.
Okay, sir, got it.
It will only give you X then. Yeah.
Sir, I have a doubt.
Yes.
Sir, instead of pre-multiplying, if we just do the normal way, will there be any error?
What do you mean by normal way?
Like just multiplication rather than pre-multiplying it by A inverse.
Just say multiply by A inverse. But the problem is if you multiply by A inverse from the right side, there is an X in the middle, so these two won't cancel.
No, sir, no, I didn't mean like that. Like just instead of pre-multiplying by A inverse, we can just do A times X is equal to B, then we get an equation, right? So we can substitute using that.
I don't understand. Yeah, without bringing in A inverse, you do it, you are saying.
Yeah.
Okay, how do I do A into X? A into X is this, right?
Yes, sir. So we can do the matrix multiplication.
Okay, you do the matrix multiplication, only get the equations back.
Okay. Yeah.
You will go back to the original question and which is unsolved. You will have the three equations back with you, but you won't have X, Y, and Z.
Okay, sir. Yeah, I understand.
You have to use the A inverse concept. Sahil, did you get the answer?
So I'm still doing it.
Okay, where did you reach, Sahil?
So I'm just doing the multiplication now.
Okay. You need to tell me if you are not able to understand something there. Sahil?
So I understood. At this point, I understood. That's it.
Okay. Aishi?
Understood, sir. I got the answer.
Okay. Reina?
So understood, sir.
Neha?
Yes, sir, I understood.
Pranavi?
Yes, I understood.
Purvika finished?
Got it, sir. Done.
Vedant?
Yes, sir. I made a mistake in between, but now I got it.
Yeah. Sumera?
Yes, sir.
Sahil, tell me when you finish, Sahil.
So I finished now.
Okay. So let's quickly try another question. Okay. We're going to do this question 63, which has got a small problem there. Let's start doing and then you will understand it. I want all of you to copy the equation first. You are going to write like 1 into 1 by x, like that. I mean, it's not even necessary. Write it as 1 by x, no problem. 1 by x plus 2 by y plus 1 by z is equal to 7 is your first equation. Second is 1 by x plus 0 plus 3 by z is equal to 11. The third is 2 by x minus 3 by y plus 0 is equal to 1. Do you understand why I added a 0? Because there are terms missing. The y term missing in the second equation, the z term missing in the third equation. And then we will convert it into a matrix equation. So we're going to write the matrix equation now. So if you look at the matrix equation, the first matrix, I'm going to list out the coefficients. Nahat, can you tell me the coefficients from the first equation?
Yes, sir. It is 1, 2, 1.
From the second equation?
1, 0, 3.
Third equation?
2 minus 3, 0.
Okay. Into the variable part is this time not x, y, and z. The variable part this time is 1 by x, 1 by y, and 1 by z. That's a change. The variable from the left hand side is not x, y, and z. It is 1 by x, 1 by y, and 1 by z. So equal to the right hand side will be 7, 11, and 1. Do you all see the small change? Instead of x, y, z, you will be getting 1 by x, 1 by y, and 1 by z. And so take reciprocals to get x, y, and z at the end. That's the only small change. Okay. We call it as ax is equal to b. Still we call it as ax is equal to b. Therefore, x will be shift a to the other side. And when I shift a to the other side, it becomes a inverse. Yeah. When I shift a to the other side, it becomes a inverse into b. Basically, this is pre-multiplied. Neha, you need to mute. So you pre-multiply by a, and that gives me x is equal to a inverse into b, which is equation number 1. So what's the next step then going to be after this? You need to see. Sahil, what is our next step? What should I do to find out a inverse? What's the first thing you will do to find out a inverse?
Yes, sir.
Sahil, what should I do to find out A inverse first?
Find A inverse.
How do I find out A inverse? What's the first thing to find out A inverse?
So it'll be A inverse equals x into b. So
how do I find A inverse? Now, don't you do, what is the first step to find out A inverse?
So I'll be find determinant of A.
Find determinant of A. Find determinant of A. Determinant 1, 2, 1, 1, 0, 3, 2 minus 3, 0, which is equal to 1 into 0 minus minus 9 minus 2 into 0 minus 6 plus 1 into minus 3 minus 0. So that's going to be minus plus 9 plus 12 minus 3. And that's going to be 18. Determinant A is 18. Now I need the cofactors to be done. A11 will be plus of, A12 will be minus of, and A13 will be plus of. A21 will be minus, A22 will be plus, and A23 will be minus. A31 will be plus, A32 will be minus, A33 will be plus. So plus of, calculate its minor. A11 minor is 0 minus 9, which is 9. A12 will be 0 minus 6, which is 6 now. A13 will be minus 3 minus 0, which is minus 3. A21 will be A21. I'm here. Delete the row and the column. Cross multiply. You'll get 0 minus minus 3. It's minus 3. A22 will be plus of, A22 is out here. Delete the row and the column it contains. Cross multiply 0 minus 2. Then A23, it's here. Delete the row and the column. Cross multiply minus 3 minus 4. And A31 will be delete the row and the column. Cross multiply 6 minus 0. 6 minus 0, which is 6. A32 will be, that's the element. Delete the row and the column. Cross multiply 3 minus 1. Which is minus 2. And A33 will be, that is the element. Delete the row and the column. Cross multiply. You will get 0 minus 2. So I have the cofactors done. So I'm going to write my A inverse. So A inverse will be 1 by determinant A into adjoint of A. So 1 by 18 into adjoint of A. Read the row and write as the column. Then minus 3, minus 2 and 7. Then 6, minus 2 and minus 2. Then we put it back into equation number 1, which says x is equal to A inverse into B. In fact, x is 1 by x, 1 by y, 1 by z. It's equal to A inverse I already have with me. So 1 by 18 into 9 minus 3 is 6. 6 minus 2 minus 2. Minus 3, 7 and minus 2 into B. B is 7, 11, 1. Multiply 1 by 18. 9 into 7, 63 minus 33 plus 6. I'll get 1 by x as 2, 1 by y as 1, and then I'll get 1 by z as 3. Therefore, x will be 1 by 2, y will be 1 itself, and z will be 1 by 3 is the solution.